Hello, and welcome to Backer Breaks It Down. In today's episode, we take a look at the Pythagorean Theorem. So the Pythagorean Theorem works for right triangles. Okay. In a right triangle, we call the side opposite the right angle the hypotenuse, and we call the other two sides legs. And so the Pythagorean Theorem, most of us know it as a squared plus b squared equals c squared. Where A and B are the legs and C is the hypotenuse. So I like to think of it as the leg squared plus the other leg squared equals the hypotenuse squared, because that's really what that's saying. Okay. There are these things called Pythagorean triples, and they're just patterns, and we will take a look later at how you can use Pythagorean triples as a shortcut. But that's really what they are shortcuts. So, like, if you really don't feel like using the Pythagorean theorem, maybe you can use a triple and figure out the missing side that way. But more to come on that later. We're going to focus on using our Pythagorean theorem to find missing sides of right triangles. That's where we're going to start. So use the Pythagorean theorem to find the value of x. If necessary, express as a radical in simplest form. Okay, so I have to realize that the 14 is my hypotenuse. So for all of us, a squared plus b squared equals c squared people, that's the value of c, because c is the hypotenuse. So the other two sides are your a's and b's. So but I like it as the leg squared, so x squared, plus the other leg squared, 7 squared, is equal to the hypotenuse squared. Okay. And so then I can do my math. I generally just do it all at once, but for you guys, I'll do it step by step. So I have x squared plus 49 is equal to 196. And then I would subtract 49 from both sides, of course, and I get that x squared is equal to 147. And then I would go and I would take the square root of this. Now, I do want you to express this in simplest radical form. So let's talk about the square root of 147 because, yeah, it's not a perfect square. When I look at the number 147, I see 14 and then I see 7. That's where my brain works. But because that's the way my brain works, I know I can divide it by 7, right? Because 14 divided by 7 is 2, and 7 divided by 7 is 21. And then 21 is 7 times 3. So I didn't identify that largest perfect square right off the bat, but I did ultimately find a perfect square if you think about it, because 7 times 7, well, that's 49. So really 147 is 49 times 3. And if I simplify that square root style, I would get 7 square root of 3. A soccer field is a rectangle 90 meters wide and 120 meters long. So 90 by 120. The coach asks players to run from one corner to the corner diagonally across. How many meters do the players run? Approximate your answer to the nearest 10. So this is what the players are running on. And so that's what we want to find. And so the corner of the field is a right angle. And so they want me to find the hypotenuse. So I would be the leg squared plus the other leg squared is equal to the hypotenuse squared. So I do the math and I get 22,500 is x squared. And then I take the square root of that. And I get x is 150 meters exactly. So earlier, remember I was talking about Pythagorean triples? What we just saw here was one of them. This was if you think about it, I mean, it was 90 and 120, but 9, 12, 15. Okay, so 90, 120, and 150 are a Pythagorean triple because they're a multiple of 30. of the 3 by 4 by 5. So just something to like think about, even though we're going to talk about it more later, like, you know, what do you notice? What do you wonder? Okay. Number 3, find the area of an isosceles triangle. Well, area of a triangle, we all know that formula, is half the triangle's base times the triangle's height. Now, like, I can see that the base, that's what the 6 feet is. So the base is 6. And then they're indicating that it's been divided into 2 congruent parts. So each part would be 3. But notice that I don't know what the height is. Okay, so I'm going to have to use my Pythagorean theorem to find it. So the leg squared plus the other leg squared is the hypotenuse squared. So I end up getting that h squared is 40, and then I can take the square root of that. Now, it doesn't say whether or not we should write this in simplest radical form, so I guess I will. So 40 is 4 times 10, so that'd be 2 root 10. So now I got the height. So now I'm ready to put all the pieces together and find the area, because the area is half base times height. So for us, we're looking at half, and then the base is 6, and then the height is 2 root 10. So remember, when I'm multiplying with radicals, I can multiply all the outsides together. And then, well, the 10 on the inside doesn't have anything to multiply with, so he's just going to have to stay all by himself on the inside. But I end up with an area of 6 root 10 square feet. Now, I know there's an example 4 in your notes, but I feel that we should say that one for class because it's a good one to do together, okay? But that's the Pythagorean theorem. We can use this to find missing sides in a right triangle. A squared plus b squared equals c squared is the leg squared plus the other leg squared is equal to the hypotenuse squared. And that's how Backer breaks it down.